Imagine standing at the entrance of a limestone cave in southern France. The morning mist settles across ancient valleys where mammoths once grazed. Your fingers trace weathered handprints pressed into clay 40,000 years ago, small, delicate impressions alongside larger ones. These aren't the hands of your direct ancestors. They belong to a different kind of human, Neanderthals. For decades, science told us these were primarily male hands, hunters who dominated their world through brute strength while females remained passive observers. But what if everything we thought we knew about Neanderthal women was wrong? Recent research suggests something extraordinary and barely whispered in academic circles. Neanderthal women may have possessed physical capabilities that would humble even elite modern female athletes. Their muscle mass, bone density, and raw power potentially exceeded that of average modern men. Yet these aren't the brutish caricatures of old textbooks. The emerging portrait reveals sophisticated beings with advanced social structures, artistic capabilities, and survival skills. At the center of this revelation stands a figure science has consistently underestimated: the Neanderthal woman. For over a century, researchers have reconstructed Neanderthal society through a distinctly male lens, emphasizing hunting, territorial defense, and competition. But buried within fossilized bones, ancient DNA, and archaeological context lies evidence that tells a very different story. A story of female power that challenges not only our understanding of prehistory, but the very narrative of human evolutionary progress. If Neanderthal women wielded physical and social influence beyond what we've assumed, what does this reveal about our own biases in interpreting the past? More unsettlingly, if these remarkable women possessed capabilities beyond modern humans, what does this suggest about our supposed evolutionary advancement? Have we, in fact, lost something profound along our journey to becoming Homo sapiens? The paradox deepens when we consider their disappearance. How could beings with such apparent advantages vanish while our more gracile ancestors flourished? The answer may lie not in their weakness, but in aspects of female Neanderthal biology we've only begun to understand. Tonight, we venture into the shadows of prehistory to uncover what may be the most misunderstood figure in human evolution: the Neanderthal woman. We'll examine emerging evidence that suggests her dominant role in hunting, childcare, technological innovation, and even interbreeding with our ancestors. We'll explore how bone structures reveal extraordinary strength that would surpass modern Olympic athletes. We'll investigate cave art potentially created by female hands, challenging centuries-old assumptions about prehistoric gender roles and creativity. Archaeologists are now discovering evidence of tools and artifacts likely designed specifically for female activities, implements whose function remained mysterious until researchers finally thought to examine them through a female perspective. Most provocatively, we'll delve into the genetic fingerprints these women left within our own DNA, traces that suggest they may have possessed unique cognitive and physical abilities that provided crucial evolutionary advantages during periods of climatic crisis. Their genes influence everything from our immune systems to brain development, raising questions about what other Neanderthal female traits might lie dormant within us. Traits we've inherited but never fully recognized or understood. The traditional narrative portrays Neanderthals as evolutionary dead ends, outcompete by our cleverer ancestors. But what if their disappearance wasn't failure but transformation? A genetic and cultural merger with early Homo sapiens, where female Neanderthals played the decisive role. Recent skeletal analysis reveals that Neanderthal women carried significantly more muscle mass than even the strongest modern human females. Their arm bones show development comparable to today's elite male athletes, suggesting routine activities requiring immense upper body strength. But physical prowess represents just one dimension of the emerging portrait. New interpretations of burial sites suggest female Neanderthals may have held ceremonial significance. Bodies carefully positioned, adorned with ochre and flowers, challenge our assumptions about prehistoric social hierarchies. The mystery deepens when we examine the spaces where they lived. Cave sites across Europe reveal evidence of sophisticated living arrangements, specialized areas for different activities, with some researchers now suggesting distinct female workspaces where crucial technologies were developed and refined. What makes this revelation so profound is how thoroughly it contradicts a century of scientific consensus. The image of the club-wielding male Neanderthal has persisted not because of overwhelming evidence, but because of the cultural biases of those studying the remains. Tonight, we will explore what happened when scientists finally began asking different questions about these women, and why the answers they found remain so controversial. We'll examine how new technology is allowing us to peer into their lives with unprecedented clarity. We'll meet the female archaeologists and paleoanthropologists leading this research revolution, often facing resistance from established academic structures as they overturn long-held beliefs about our evolutionary cousins. And we'll confront the most challenging question of all. If Neanderthal women possessed such remarkable capabilities, why did they vanish? The answer may force us to reconsider everything we thought we knew about human evolution, gender roles, and the true nature of progress. Tonight, we venture into the gap that science is still struggling to explain, the untold power of the Neanderthal woman, and the secrets that remain hidden in plain sight. Let's begin our journey into a past more complex and surprising than we ever imagined. Chapter 2: The Stakes of Rewriting Prehistory. The significance of this story extends far beyond academic curiosity. If Neanderthal women truly possessed the physical and social capabilities now being suggested, the implications ripple through multiple dimensions of how we understand ourselves, biologically, culturally, and philosophically. For generations, we've constructed an evolutionary narrative that places Homo sapiens at the pinnacle of development. Our supposed intelligence, innovation, and adaptability triumphed over the brutish, primitive Neanderthal. This comforting story reinforces our belief in human exceptionalism and linear progress. But what if Neanderthal women were not the passive, subservient figures of outdated textbooks? What if they were physically stronger than most modern humans, capable of sophisticated technological innovation, and possibly even the primary drivers of their societies? The evidence forcing this reconsideration comes from multiple disciplines. Paleopathologists studying Neanderthal skeletal remains now identify stress markers and muscle attachments, suggesting women routinely performed activities requiring extraordinary upper body strength, activities that would physically cripple modern humans. Genetic analysis reveals Neanderthal females contributed significant DNA to our genome, particularly genes related to immune function, skin and hair properties, and even brain development. Their genetic legacy lives within us, raising profound questions about what truly constitutes evolutionary success. Archaeological contexts show tools and living spaces that, when examined without gender bias, suggest female-centric activities requiring remarkable precision and innovation. The very technologies once attributed exclusively to males may have been female domains. If confirmed, these findings demand we reconsider fundamental assumptions. The image of prehistoric gender roles, man the hunter, woman the gatherer, collapses. The supposed physical inferiority of females across human evolution becomes questionable. Our assumptions about social organization require complete revision. More profoundly, it forces us to confront the possibility that modern humans didn't simply replace Neanderthals because we were better. Rather, the complex interaction between our species may have involved Neanderthal women making calculated decisions about reproduction and cultural exchange. This matters because how we understand our evolutionary past shapes how we perceive human potential in the present. If female physical capacity was dramatically different in our near relatives, what does this reveal about biological determinism arguments that persist today? If Neanderthal societies operated with fundamentally different gender dynamics than we've assumed, what might this suggest about the cultural rather than biological basis for modern gender roles? The political implications of this research extend far beyond prehistory. Consider what changes if we discover that Neanderthal women were primary hunters in their communities. Traditional archaeology has interpreted hunting injuries on male skeletons as evidence of exclusively male hunting parties. But similar injuries now identified on female remains challenge this narrative. Some researchers propose that Neanderthal females, with their robust physiology and superior upper body strength, may have been ideally suited for close-quarter hunting techniques, thrusting spears into large prey at short distances, a high-risk strategy requiring immense power and precision. This possibility disrupts centuries of assumptions about the division of labor in prehistoric societies. If Neanderthal women routinely participated in or even led hunting activities, the entire foundation of evolutionary psychology regarding gender roles requires reconstruction. The stakes extend to how we interpret our own genetic inheritance. Between 1 to 4% of non-African human DNA comes from Neanderthals, with some populations carrying even higher percentages. These aren't random fragments, but selected traits that offered advantages in specific environments. Many of these adaptive traits appear to have come specifically from Neanderthal females. Recent genomic studies suggest gene flow was predominantly from Neanderthal women to Homo sapiens, raising the possibility that their unique physiological and cognitive adaptations were specifically selected for. What makes this particularly relevant is how these genes continue to influence human health and development today. Neanderthal DNA affects everything from pain sensitivity to immune response to depression susceptibility. We literally experience the world through senses partly shaped by Neanderthal women. Yet perhaps the most profound implication concerns the nature of strength itself. For centuries, human societies have defined strength primarily through male physiology and capabilities. But Neanderthal females appear to have embodied a different model altogether, one that combined remarkable physical power with sophisticated social cooperation. Their apparent strength didn't exist in isolation, but within complex social structures. Evidence suggests Neanderthals cared for injured and elderly community members, shared resources, and potentially developed sophisticated communication systems. What if these social technologies were primarily female domains? This possibility challenges the persistent narrative that aggression and competition drove human evolution. If Neanderthal women exercised power through cooperation and community building rather than dominance, we may need to reconsider the very nature of evolutionary advantage. For scientists, the stakes involve confronting uncomfortable biases in how research questions are formulated. For decades, archaeological finds were interpreted through the lens of male-dominated narratives. Female remains were often misidentified or their significance downplayed. Consider the revelation that approximately 30% of assumed male Neanderthal remains, when subjected to modern DNA analysis, turn out to be female. This systematic misattribution reveals how powerfully preconceptions influence supposedly objective scientific observation. When researchers finally began asking different questions, examining female remains with the same attention previously given to males, considering alternative interpretations of living spaces and artifacts, an entirely different picture of Neanderthal society began to emerge. This matters because science shapes our understanding of human possibility. If prehistoric females possessed capabilities we've systematically underestimated, what other aspects of human potential have we misunderstood? How have our biases limited our understanding of ourselves? Beyond scientific implications lie deeper philosophical questions. The traditional narrative positions Homo sapiens as the pinnacle of evolution, cleverer, more adaptable, ultimately more successful than our robust cousins. But success in evolutionary terms is complex and contextual. Neanderthals survived harsh climatic conditions for over 300,000 years, far longer than our species has existed. They adapted to extreme environments, developed sophisticated technologies, and potentially created art and symbolic objects. Their disappearance may reflect not inferiority, but complex population dynamics. If Neanderthal women possessed remarkable physical capabilities, sophisticated social structures, and unique cognitive adaptations, their absorption rather than replacement by Homo sapiens suggests a more nuanced evolutionary story, one where different human populations contributed complementary strengths to our species. This fundamentally changes how we understand ourselves. Rather than conquerors who displaced lesser human varieties, we become the beneficiaries of multiple evolutionary experiments, including the remarkable adaptations of Neanderthal women, whose genetic and possibly cultural legacy continues within us. Chapter 3: Ice Age Queens, the World They Ruled. To understand the true significance of Neanderthal women, we must first journey into their world, a harsh, demanding landscape that shaped their biology, technology, and social structures. Their story begins approximately 400,000 years ago, as a distinct human lineage emerged in Europe and Western Asia. The Europe they inhabited bore little resemblance to today's landscape. ice sheets advanced and retreated across the continent, transforming environments from tundra to forest and back again within single lifetimes. Temperatures could plummet 20 degrees in a generation. This environmental instability required extraordinary adaptability. Neanderthal bodies evolved for cold resistance, with shortened limbs, barrel chests, and robust builds that conserved heat efficiently. Their facial structure, pronounced brow ridges and large nasal cavities, warmed air before it reached their lungs. But these weren't just survival adaptations. They created bodies capable of generating and sustaining tremendous physical power. Skeletal evidence suggests Neanderthals possessed approximately 50% more upper body strength than modern humans, with females showing particularly significant development. Unlike the relatively slight sexual dimorphism seen in Homo sapiens, Neanderthal males and females shared many of these robust features. Female Neanderthals were likely shorter than males, but possessed comparable muscle development, bone density, and cold-adapted proportions. This physiological reality challenges our assumptions about prehistoric gender roles. Modern humans project a narrative of male strength and female fragility onto the past, but Neanderthal biology tells a different story, one where female robusticity approached or matched that of males. Their world demanded this strength. The Pleistocene Europe of the Neanderthals featured megafauna we can scarcely imagine today: woolly mammoths standing 14 feet tall, cave bears weighing over a ton, massive bison and aurochs moving in vast herds across the steppe. Hunting these animals required not just physical power, but sophisticated coordination and technology. The spears Neanderthals crafted were heavy thrusting weapons designed for close-quarter kills, a high-risk strategy demanding incredible upper body strength and precise timing. Marks on Neanderthal bones reveal the dangers of this lifestyle. Many skeletons show healed fractures similar to those seen in modern rodeo riders, evidence of close physical contact with large, powerful animals. Significantly, these injury patterns appear on both male and female remains. This challenges the traditional narrative that Neanderthal women remained safely in caves while men faced danger. The evidence suggests women routinely participated in activities involving substantial physical risk and close contact with large prey animals. Their adaptation to this demanding lifestyle wasn't merely physical. Neanderthal brains were actually larger than those of modern humans, with particular development in areas associated with vision and body control, crucial for navigating complex physical environments and coordinating precise movements. While brain size isn't directly correlated with intelligence, this neural development suggests cognitive specialization for their lifestyle. Neanderthals possessed extraordinary spatial awareness, environmental memory, and likely sophisticated understanding of animal behavior. Their social structures remain more mysterious, but mounting evidence suggests complex arrangements beyond simple male dominance hierarchies. Burial sites show no clear pattern of differential treatment between males and females, suggesting status may have been determined by factors other than sex. Particularly intriguing is evidence of care for injured individuals. Multiple Neanderthal skeletons show severe injuries that would have prevented hunting or gathering, yet these individuals survived for years after being injured, indicating community support and food sharing. This suggests a social structure emphasizing cooperation and interdependence, qualities traditionally associated with female social organization in many hunter-gatherer societies. Rather than rigid gender roles, Neanderthals may have developed more fluid arrangements based on individual capability. Their material technology reveals sophisticated adaptation to their environment. They crafted specialized tools for different purposes: scrapers for preparing hides, points for hunting, cutting tools for butchery. Evidence suggests they developed adhesives requiring complex processing of plant materials. Perhaps most significantly, they controlled fire, that quintessential human technology that transforms environments, materials, and social relations. Hearths found in Neanderthal sites show evidence of repeated use, carefully maintained temperatures, and specialized cooking areas. Fire would have been particularly crucial for Neanderthal women during pregnancy and nursing. In cold environments, maintaining body temperature while diverting energy to fetal development presents a significant challenge. Control of fire enabled successful reproduction in harsh climates. The traditional narrative portrays Neanderthals as technologically stagnant compared to Homo sapiens. But this view increasingly appears to reflect research bias rather than reality. Their technology was sophisticated and highly adapted to their specific environmental challenges. What's emerging is a picture of Neanderthal adaptations specifically suited to their environment and lifestyle, not inferior to those of Homo sapiens, but different. Their physical power, spatial cognition, and cold adaptation represented highly successful evolutionary strategies for Ice Age Europe. Within this context, Neanderthal women appear not as subordinate figures, but as central to their society's survival. Their robust physiology enabled crucial contributions to subsistence activities, while their reproductive biology faced unique challenges in harsh environments. Evidence suggests Neanderthal women gave birth to infants with larger brains relative to body size than modern humans, an adaptation requiring significant metabolic resources and potentially longer developmental periods. This reproductive investment would have shaped social structures. Archaeological sites reveal communal living spaces with evidence of food processing, tool manufacturing, and childcare occurring in close proximity. The traditional separation of domestic and hunting spaces may be a modern projection rather than prehistoric reality. This integrated living arrangement suggests children were raised in environments where they observed and participated in adult activities from an early age. The transmission of complex technical knowledge, how to craft tools, process materials, hunt effectively, likely occurred in these contexts. By approximately 100,000 years ago, Neanderthals had developed distinctive cultural traditions across Europe and Western Asia. Regional variations in tool styles suggest local innovation and adaptation, contradicting the image of a species resistant to change or lacking creativity. Their world began to transform dramatically around 50,000 years ago, when a new human species, Homo sapiens, began expanding into Neanderthal territories. These newcomers brought different technologies, social structures, and adaptations to the European landscape. The traditional narrative portrays this meeting as a simple replacement, clever Homo sapiens outcompeting their archaic cousins. But genetic evidence reveals a far more complex interaction. Neanderthals and Homo sapiens didn't just compete, they interbred. And here lies perhaps the most revolutionary aspect of recent research. This interbreeding appears to have been primarily between Neanderthal females and Homo sapiens males. The genetic evidence suggests directional gene flow, raising profound questions about the nature of these encounters. Were these unions cooperative or coercive? Did they represent strategic alliances between groups or individual choices? The archaeological record provides few clear answers, but the genetic legacy remains within us, particularly in populations outside of Africa. This prehistoric context, a harsh, demanding landscape where physical strength conferred survival advantages, where complex technologies were necessary for subsistence, and where eventually two human species encountered each other, forms the backdrop for our understanding of Neanderthal women. Chapter 4: Bodies of Evidence. The physical truth, the most direct evidence of Neanderthal female capabilities, comes from their bones. For decades, these remains were interpreted through modern assumptions about gender. Robust features automatically classified as male, more gracile specimens as female, often without rigorous analysis. Recent re-examinations using DNA analysis and more sophisticated morphological techniques have revealed surprising patterns. Many specimens long classified as male are actually female, demonstrating that Neanderthal women possessed levels of robusticity that would appear masculine by modern human standards. The implications are profound. Female Neanderthal skeletons exhibit muscle attachment sites, suggesting strength capacities far exceeding those of modern human females. Their humeral bones, indicators of arm strength, show development comparable to elite male athletes today. Their hand bones tell an equally remarkable story. Neanderthal females possessed extraordinarily powerful grip strength, with metacarpal bones showing stress markers consistent with routine activities requiring precise, yet forceful manipulation, spear thrusting, animal hide processing, and tool crafting. These weren't simply strong women by modern standards. Evidence suggests Neanderthal females possessed upper body strength exceeding that of average modern males. Their bones show thickness, density, and muscle attachment sites, indicating capabilities that would appear superhuman by contemporary standards. Lower body evidence reveals equally impressive development. Neanderthal females had extremely powerful leg musculature, with femurs showing massive muscle attachment sites. Their knee and ankle joints demonstrate adaptations for generating and absorbing tremendous force during movement. What activities produced these remarkable adaptations? Analysis of wear patterns and stress markers suggests repetitive motions involving powerful rotation of the upper body, forceful thrusting movements, and carrying heavy loads across variable terrain. These patterns align perfectly with what we know of Neanderthal subsistence strategies. Close-quarter hunting requiring powerful spear thrusts, processing large animal carcasses, transporting heavy loads of meat and materials across rugged landscapes in harsh climatic conditions. Particularly telling are the similarities between male and female remains. While Neanderthal males were generally larger, females show comparable patterns of muscle development and stress markers, suggesting they participated in many of the same physically demanding activities. This challenges the traditional narrative of strict division of labor along gender lines. If Neanderthal women routinely engaged in activities requiring extraordinary strength and endurance, our assumptions about prehistoric gender roles require fundamental reconsideration. Injury patterns provide further insights. Both male and female Neanderthal remains show similar patterns of healed fractures, particularly to the head, neck, and upper body, consistent with close encounters with large animals and hazardous activities. A particularly illuminating case comes from the remains known as Shanidar 4, a female Neanderthal from Iraq showing multiple healed injuries consistent with close-quarter hunting. She survived these encounters and continued performing physically demanding activities despite her injuries. Similar patterns appear across female specimens from different regions and time periods. These weren't anomalies or exceptions. They represent the normal physiological condition of Neanderthal women adapted to their demanding lifestyle. Dental evidence adds another dimension to our understanding. Neanderthal teeth frequently show non-dietary wear patterns, evidence of using their mouths as third hands for gripping materials during processing activities. These patterns appear with similar frequency in female and male specimens. Isotope analysis of teeth provides insights into diet, revealing that Neanderthals were primarily carnivorous, deriving most of their calories from large herbivores. Significantly, female remains show the same dietary signatures as males. They were consuming the same high-protein, meat-heavy diet. This contradicts assumptions that prehistoric females primarily gathered plant foods while males hunted. Neanderthal women were routinely consuming quantities of animal protein consistent with direct participation in hunting rather than secondary access to meat. Reproductive biology reveals another dimension of female Neanderthal physiology. Pelvic reconstructions suggest they gave birth to infants with larger cranial capacities relative to maternal size than modern humans, a challenging adaptation requiring substantial skeletal modifications. The Neanderthal birth process was likely even more difficult than that experienced by modern humans, who already face significant obstetrical challenges compared to other primates. This reproductive investment suggests Neanderthal infants required extensive postnatal care. Such demanding reproductive biology would have shaped social arrangements. The combination of physically demanding subsistence activities and high maternal investment suggests cooperative child-rearing strategies, a social adaptation as significant as any technological innovation. Evidence of these arrangements appears in living sites, where communal spaces show activities occurring in close proximity. Rather than separated male and female domains, Neanderthal sites suggest integrated living arrangements where children were exposed to all aspects of adult activity. The physical evidence extends beyond bones to the artifacts Neanderthals created and used. Their stone tools required tremendous hand strength to produce and use effectively, particularly the heavy thrusting spears that served as their primary hunting weapons. Experimental archaeology demonstrates that using these tools effectively requires not just technique, but substantial physical power. Modern researchers, regardless of gender, struggle to generate the force necessary to drive Neanderthal spears into large animal carcasses. This raises a provocative question. If Neanderthal females possessed greater upper body strength than most modern males, could they have been equally effective at using these hunting technologies? The physical evidence strongly suggests they could. New analytical techniques are revealing even more direct evidence of female activities. Microscopic examination of wear patterns on tools, residue analysis, and fingerprint studies are beginning to identify specific artifacts that were likely made and used by female Neanderthals. A particularly intriguing discovery comes from fingerprint analysis of clay found near hearths in several Neanderthal sites. These impressions, likely left during hearth construction or cooking activities, include a high percentage of prints from female hands, based on ridge density patterns. Similarly, handprints found in cave art contexts, long assumed to be exclusively male, are now being reassessed. New analysis techniques suggest many of these prints, previously classified as adolescent males, may actually represent adult Neanderthal females. The emerging physical evidence creates a portrait fundamentally different from traditional depictions. Neanderthal women possessed physical capabilities that would appear extraordinary by modern standards: strength, endurance, and resilience suited to their demanding Ice Age world. This evidence doesn't suggest occasional female participation in physically demanding activities, but routine engagement with the full spectrum of survival tasks. The physical adaptations visible in female remains developed through consistent, lifelong performance of demanding activities. Such capabilities would have conferred significant influence within Neanderthal social structures. In environments where physical strength directly correlated with survival capacity, female Neanderthals' robust physiology would have translated to social standing and decision-making power. This reconstruction conflicts dramatically with popular depictions of prehistoric women as physically limited, dependent figures. The evidence suggests Neanderthal females were formidable beings, capable of bringing down large prey, defending their communities, and thriving in environments that would challenge even the hardiest modern humans. Yet the most provocative aspect of this evidence isn't just what it tells us about Neanderthals, but what it suggests about ourselves. If female physical capability was so different in our evolutionary cousins, might our assumptions about human gender biology require radical revision? The traditional narrative holds that modern humans replaced Neanderthals through superior intelligence and adaptability. But as evidence of Neanderthal capabilities grows, particularly female capabilities, this simplistic account becomes increasingly questionable. What emerges instead is the possibility that Neanderthal women weren't replaced but absorbed, their genes, their adaptations, and possibly elements of their culture merging with those of incoming Homo sapiens. The conventional story of replacement transforms into one of incorporation. But this leads to the most perplexing question of all, one that haunts paleoanthropologists and evolutionary biologists alike. If Neanderthal females possessed such remarkable physical capabilities, why did these traits largely disappear from the human lineage? Why would natural selection, which typically preserves adaptive traits, allow the extraordinary strength of Neanderthal women to fade from our species? What changed in our ecological circumstances or social arrangements that rendered such physical power unnecessary or even disadvantageous? The answer may lie in a profound shift in the relationship between biology and technology, a transformation in how humans related to their environment that forever altered the course of female physical evolution. A change that began approximately 40,000 years ago. Recent discoveries from a cave site in Croatia have uncovered female Neanderthal remains dating to this critical transition period. The skeleton shows something remarkable, a hybrid morphology with features of both Neanderthal robusticity and Homo sapiens gracility. DNA analysis confirms what the bones suggest. This individual carried genetic markers of both species. She represents a living embodiment of the momentous biological and cultural shifts occurring as two human lineages encountered each other after hundreds of thousands of years of separate evolution. What makes this discovery particularly significant are the artifacts found alongside her remains. Tools showing technological elements from both Neanderthal and Homo sapiens traditions, suggesting not just genetic but cultural exchange between the populations. This single burial site encapsulates the larger story of what happened when these different human groups met. Not simple replacement, but complex interaction, biological and cultural exchange, and ultimately transformation of both populations into something new. And here lies the cliffhanger in our story, the mystery that continues to elude scientific consensus. If Neanderthal women possessed such remarkable capabilities, what forces drove their disappearance? Was it competition, climate change, or something more complex involving the very nature of being human? Chapter 5. The Physiology Paradox. When science contradicts itself. The most perplexing contradiction in the Neanderthal woman story emerges when we examine the conventional narrative against emerging evidence. For decades, researchers constructed a vision of physically dominant Neanderthal males paired with comparatively passive females, a projection of modern gender assumptions onto prehistoric bodies. Yet the skeletal evidence tells a fundamentally different story. Female Neanderthal remains consistently show muscle attachment sites, bone density, and joint development, suggesting physical capabilities far exceeding not just modern women, but most contemporary men. This creates a profound scientific contradiction. If natural selection favors traits that enhance survival and reproduction, why would Neanderthal females evolve such extraordinary physical capabilities only to remain relegated to secondary roles in their societies? Evolution doesn't waste energy. The metabolic cost of maintaining such muscular development would be substantial, requiring significant caloric intake. If these adaptations weren't essential to female survival and reproductive success, they would have been selected against, not amplified. The contradiction deepens when we examine specific anatomical features. Female Neanderthal shoulder development shows adaptations for powerful rotational movements, precisely the biomechanics needed for effective spear thrusting during close-quarter hunting. Their hand morphology reveals another anomaly. While modern human females typically have more gracile hands with less powerful grip strength than males, Neanderthal women possessed hand musculature and bone density approaching that of their male counterparts. These hands were perfectly adapted for manipulating heavy tools, processing animal hides, and potentially delivering lethal thrusts with hunting implements. The physical evidence suggests not occasional participation in these activities, but routine, lifelong engagement. Recent biomechanical analysis of female Neanderthal remains from El Sidrón Cave in Spain revealed stress markers indicating habitual movements involving tremendous upper body power. These weren't anomalous individuals, but representatives of normal female Neanderthal physiology. This evidence directly contradicts the traditional narrative of strict gender division in prehistoric task allocation. If Neanderthal women possessed physical capabilities suited for hunting and heavy processing work, the conventional image of passive females engaged only in childcare collapses. Yet another contradiction emerges when we examine isotopic evidence from Neanderthal teeth. Both male and female remains show nearly identical chemical signatures indicating a heavily meat-based diet. There's no evidence of dietary differentiation by gender. This contradicts assumptions that prehistoric females consumed more plant foods while males had preferential access to animal protein. Neanderthal women were consuming quantities of meat consistent with direct participation in hunting, not secondary access to kills. Perhaps the most significant contradiction involves reproductive biology. Neanderthal pelvic structure indicates they gave birth to large-brained infants, a process requiring substantial physical resilience. Yet they maintained extreme physical robusticity throughout their adult lives. Modern medical understanding suggests pregnancy and nursing typically reduce bone density and muscle mass in human females. How did Neanderthal women maintain such extraordinary physical development while managing the demands of reproduction in harsh Ice Age environments? This paradox has forced researchers to reconsider fundamental assumptions about prehistoric life. Rather than imposing modern gender divisions onto the past, evidence suggests Neanderthals may have developed more integrated social arrangements where capabilities, not gender, determined roles. Equally contradictory is the traditional narrative regarding Neanderthal cognitive capacity. For decades, they were portrayed as intellectually inferior to Homo sapiens, yet their brain size actually exceeded that of modern humans, with particular development in areas handling visual processing and motor control. Female Neanderthals possessed these same neural adaptations. Their brains show the enlarged occipital lobes and cerebellum characteristic of the species, suggesting equivalent cognitive specialization for environmental navigation, tracking, and fine motor coordination. This neural architecture directly contradicts the notion that Neanderthal women lacked the cognitive capacity for complex hunting and technological activities. Their brains were specifically adapted for precisely these sophisticated environmental interactions. A particularly striking contradiction appears when examining evidence of trauma. Female Neanderthal skeletons show injury patterns remarkably similar to males, healed fractures consistent with close encounters with large animals and hazardous terrain. The traditional explanation that these injuries resulted from domestic accidents rather than hunting activities increasingly appears to be a modern projection rather than evidence-based interpretation. The pattern and frequency of these injuries match those expected from hunting large game. Consider the female Neanderthal remains from Shanidar Cave, Iraq. This individual survived multiple serious injuries, including a crushing blow to the skull and fractured ribs, continuing to perform physically demanding activities for years afterward, as evidenced by continued bone remodeling. This resilience contradicts notions of female fragility or dependency. Neanderthal women not only sustained injuries similar to those of male hunters, but recovered and continued contributing to subsistence activities despite significant physical trauma. Another anomaly emerges from dental analysis. Neanderthal teeth frequently show non-dietary wear patterns, evidence of using the mouth as a third hand during processing activities. These patterns appear with similar frequency in female and male specimens. This contradicts assumptions that females would avoid such physically demanding and potentially dangerous techniques for processing materials. Instead, they appear to have engaged in the full spectrum of technological activities, regardless of physical risk. These contradictions aren't limited to physical remains. Archaeological contexts reveal equally perplexing anomalies. Traditional interpretations of Neanderthal sites have attempted to identify separate male and female activity areas based on modern gender assumptions. Yet careful reanalysis shows integrated living spaces where tool production, food processing, childcare, and technological activities occurred in close proximity. The expected spatial separation of gendered activities simply doesn't appear in the archaeological record. This contradicts fundamental assumptions about how prehistoric societies organized themselves. Rather than rigidly divided gender roles, Neanderthal sites suggest more fluid arrangements where different activities occurred in shared spaces. Perhaps most contradictory to established narratives is the evidence regarding technological innovation. Neanderthals were long portrayed as conservative and unchanging, yet regional variations in their tool designs suggest continuous adaptation and innovation across their 300,000-year history. Recent analysis of Neanderthal artifacts reveals sophisticated adhesives requiring multi-step processing, complex composite tools, and potential symbolic objects. These technologies required not just physical capability, but advanced planning and abstract thinking. The assumption that female Neanderthals couldn't participate in creating these technologies contradicts everything we know about their physical and cognitive capabilities. Their powerful hands, spatial processing, and environmental knowledge would have been assets in technological innovation. An emerging body of evidence suggests some technologies may have been specifically female domains. Microscopic analysis of wear patterns on certain tools, combined with experimental archaeology, indicates designs optimized for powerful yet precisely controlled movements. These tool designs align perfectly with the biomechanical capabilities evident in female Neanderthal remains. Rather than technology created exclusively by and for males, Neanderthal toolkits may represent integrated design solutions for users of varying physical capabilities. The contradictions extend to how we interpret evidence of care for the injured and elderly. Multiple Neanderthal skeletons show severe injuries that would have prevented independent survival, yet these individuals lived for years after being injured. This care system contradicts notions of harsh, survival of the fittest social dynamics. Instead, it suggests sophisticated cooperation and resource sharing, social technologies potentially as important to survival as any stone tool or hunting technique. Given female Neanderthals' physical capabilities, they likely played central roles in these care systems while continuing to contribute to subsistence activities. The traditional narrative of physically limited females primarily engaged in childcare becomes increasingly untenable. Perhaps the most profound contradiction lies in how we interpret Neanderthals' ultimate fate. The conventional story portrays them as evolutionary losers, outcompeted by cleverer, more adaptable Homo sapiens and relegated to extinction. Yet genetic evidence tells a different story. Neanderthal DNA comprises up to 4% of the genome of non-African humans today. Their genes didn't disappear, but were incorporated into our lineage through interbreeding, a biological contradiction of the replacement narrative. This genetic legacy appears particularly significant in immune function, skin and hair properties, and certain aspects of brain development. These aren't random fragments, but adaptively significant traits that offered advantages in specific environments. The paradoxes and contradictions surrounding Neanderthal women force us to confront uncomfortable questions. Have we fundamentally misunderstood prehistoric gender dynamics? Have our modern biases blinded us to the true nature of our evolutionary cousins? Most provocatively, if Neanderthal females possessed such remarkable capabilities, what does their disappearance tell us about the evolutionary trajectory of our own species? What changed in the human lineage that made such physical power no longer advantageous? Chapter 6: Shadows and Stories. Myths that may be memories scattered through human folklore across multiple continents lies a curious pattern. Stories of powerful female figures with extraordinary strength, resilience, and hunting prowess. These narratives, long dismissed as fantasy, take on new significance when viewed alongside the emerging portrait of Neanderthal women. Could these myths preserve distorted memories of encounters between early Homo sapiens and Neanderthal females? The possibility becomes more intriguing when we examine the consistent attributes these legendary women possess, attributes that align remarkably with what we now know of Neanderthal physiology. Consider the widespread myths of female hunting deities found across northern Eurasia, precisely the regions where Neanderthals and early modern humans coexisted. From Artemis in Greece to Skadi in Norse mythology to the Siberian mistress of animals, these figures share distinctive characteristics. They are invariably described as physically powerful, skilled in hunting large game, and associated with cold, mountainous environments, all attributes consistent with what we now understand about Neanderthal women. Their stories frequently emphasize exceptional strength rather than magical abilities. Particularly intriguing are the consistent descriptions of their physical appearance. These mythological huntresses are typically portrayed as powerfully built, with pronounced facial features, and often described as having pale skin and reddish or light-colored hair. Recent genetic analysis confirms Neanderthals likely possessed precisely these physical characteristics. Their genetic variants associated with skin and hair pigmentation suggest many had fair skin and reddish or light hair, physical attributes that would have appeared distinctive to darker-complexioned early Homo sapiens. These myths frequently emphasize the huntress's superior knowledge of animal behavior and survival in harsh environments. Precisely the ecological adaptations Neanderthals developed over hundreds of thousands of years in Ice Age Europe. The consistency of these mythological elements across cultures that had no historical contact with each other suggests they may derive from a common experiential source rather than random imagination, potentially preserving cultural memories of encounters with female Neanderthals. Archaeological evidence provides intriguing context for such encounters. At multiple sites across Europe, archaeologists have discovered distinctive artifacts showing hybrid technological elements, tools combining typical Neanderthal design features with those associated with incoming Homo sapiens populations. These technological hybrids appear during precisely the period when genetic evidence indicates interbreeding occurred between the populations. They suggest not just physical encounters, but cultural exchange and knowledge sharing between Neanderthals and early modern humans. Particularly significant is the timing of this interaction. Approximately 40,000 to 50,000 years ago, as Homo sapiens groups were first establishing themselves in Europe. These newcomers would have encountered Neanderthal populations already perfectly adapted to local environments and resources. In such contexts, Neanderthal females' environmental knowledge, hunting skills, and physical capabilities would have been particularly valuable. Their expertise in surviving harsh European winters could have meant the difference between survival and extinction for incoming human groups. This creates a very different picture from the traditional narrative of primitive Neanderthals outcompete by superior Homo sapiens. Instead, it suggests a period of cultural and genetic exchange where Neanderthal women's unique adaptations may have been actively sought and incorporated. The mythological record contains another consistent element worth considering: stories of intermarriage between human men and powerful non-human females. These narratives appear across cultures that occupied former Neanderthal territories, from Celtic legends to Siberian folk tales. These stories typically emphasize the exceptional strength and hunting prowess of a non-human wife, who brings valuable skills and knowledge to her human husband's community. The physical descriptions of these beings, robust, powerful, skilled in wilderness survival, align with Neanderthal attributes. Genetic evidence provides a surprising corroboration. DNA analysis suggests interbreeding between Neanderthals and Homo sapiens was primarily directional. Neanderthal females with Homo sapiens males rather than the reverse. The mythology may preserve cultural memory of this genetic reality. Perhaps most compelling are the wild woman myths found across Eurasia. Stories of powerful, solitary female figures dwelling in mountains and forests, possessing extraordinary strength and knowledge of animals. These aren't portrayed as supernatural beings, but as a different kind of human. From the Russian Leshy to Germanic woodwives to the Basque Basijan, these traditions describe beings with consistent attributes: powerful build, exceptional strength, superior environmental knowledge, and distinctive appearance. They're typically portrayed as elusive but not magical. Traditionally, ethnographers have interpreted these as cautionary tales warning against wilderness dangers or symbolic representations of nature's power. But viewed alongside paleoanthropological evidence, they take on potential historical significance as distorted memories of another human species. The geographic distribution of these myths corresponds remarkably with regions where archaeological evidence confirms Neanderthal presence. The stories are most elaborate and persistent in precisely those European areas where Neanderthal populations were most concentrated. Equally significant is the timing of these mythological traditions. They appear to have crystallized during the Upper Paleolithic, the period when archaeological evidence confirms Homo sapiens and Neanderthal populations were interacting across Europe. Beyond mythology, evidence of potential Neanderthal influence appears in early human material culture. Certain artistic traditions that emerged in Europe during the period of coexistence show distinctive stylistic elements that differ from earlier Homo sapiens art in Africa. The famous Venus figurines found across Ice Age Europe typically emphasize female robusticity rather than fertility, powerful shoulders, muscular builds, and pronounced physical features. These don't match typical Homo sapiens female morphology, but align closely with Neanderthal characteristics. Could these represent not idealized female forms or fertility symbols, as traditionally interpreted, but accurate depictions of Neanderthal women? The timing and distribution of these artifacts, appearing precisely when and where the two species encountered each other, makes this interpretation plausible. Similar questions surround the emergence of certain technological traditions. The sophisticated bone tools that appear in Europe during this transition period represent a significant innovation. Were they developed independently by Homo sapiens, or did they incorporate Neanderthal knowledge? Recent experimental archaeology demonstrates that creating these implements requires not just technical knowledge, but substantial hand strength, precisely the physical capability at which Neanderthal women excelled. Their powerful grip and precise motor control would have been ideally suited for such crafting. Perhaps most provocative are the handprints found at numerous European cave art sites. Long assumed to be exclusively male, new analysis techniques examining digit ratios and hand dimensions suggest many may actually be female hands, potentially even Neanderthal female hands. The implications are profound. If Neanderthal women participated in creating what we consider the earliest human symbolic expression, our understanding of cognitive evolution and artistic development requires complete reconsideration. Beyond myth and material culture lies linguistic evidence. Some linguists have identified certain substrate elements in European languages that don't derive from known language families. Could these represent linguistic remnants from Neanderthal communication systems? While highly speculative, this possibility gains credibility when we consider the genetic evidence. If Neanderthal women integrated into Homo sapiens communities, bringing valuable skills and knowledge, some elements of their communication systems might have been incorporated as well. The traditional view that Neanderthals lacked complex language has been challenged by anatomical evidence. Their hyoid bones, crucial for speech production, were structurally similar to those of modern humans. Their ear structures suggest adaptation for perceiving the frequencies of human speech. Female Neanderthals possessed these same anatomical speech adaptations. If they joined Homo sapiens communities through interbreeding, they would have needed to communicate effectively, potentially introducing unique linguistic elements into emerging human language systems. A particularly intriguing case comes from the Basque people of southwestern Europe. Their language, Euskera, is a linguistic isolate with no confirmed relationship to any other known language family. The Basque region also happens to be an area where Neanderthal presence was particularly strong. Genetic studies show contemporary Basque populations carry some of the highest percentages of Neanderthal DNA in Europe. Could their unique language preserve elements derived from Neanderthal communication systems, transmitted through generations following interbreeding? Similarly provocative patterns appear in traditional subsistence techniques preserved in European folk practices. Certain methods for processing animal hides, creating adhesives, and crafting composite tools show remarkable similarity to techniques that experimental archaeology suggests Neanderthals employed. These processing methods often require substantial upper body strength and precise manual control, physical capabilities at which Neanderthal women excelled. Many were traditionally performed by women in historical societies, raising the possibility of direct cultural transmission. All of these converging lines of evidence, mythological, archaeological, genetic, linguistic, and technological, suggest Neanderthal women may have left a far more significant imprint on human culture than previously recognized. Rather than disappearing without trace, they may have contributed not just genes but knowledge, techniques, and cultural practices that persist in distorted form through mythology and traditional practices, shadows of a forgotten human lineage preserved in story and skill. These possibilities force us to reconsider what we mean by human and how we understand cultural transmission across different hominin groups. The emerging portrait suggests not replacement, but incorporation, Neanderthal women's capabilities absorbed into the expanding human lineage. This narrative aligns more closely with the genetic evidence than traditional replacement theories. The persistence of Neanderthal DNA in modern populations, particularly genes related to immune function, skin and hair properties, and aspects of neural development, suggests adaptive advantages. Chapter 7. What actually hangs in the balance? The ultimate question. As we delve deeper into the evidence surrounding Neanderthal women, the stakes of this scientific mystery escalate far beyond academic curiosity. What began as a reassessment of prehistoric gender roles has expanded into questions that challenge our fundamental understanding of human evolution, biology, and potential. The most profound implication concerns the very nature of what we consider progress in human evolution. For generations, we've constructed a narrative positioning Homo sapiens as the pinnacle of development, cleverer, more adaptable, ultimately more successful than our robust cousins. This comforting story reinforces human exceptionalism. It assures us that our current form represents the optimal evolutionary outcome, that our glacial bodies and expanded neocortex constitute unambiguous improvements over the Neanderthal physique and neural architecture. But what if this narrative fundamentally misunderstands what occurred? What if, rather than evolving beyond Neanderthals, we actually lost certain valuable adaptations they possessed? The implications would force a radical reassessment of our evolutionary trajectory. Consider the physical capabilities evident in female Neanderthal remains. Their upper body strength, bone density, grip power, and cold resistance represent adaptations that required hundreds of thousands of years to develop, adaptations perfectly suited to the challenging environments they inhabited. The traditional narrative frames the loss of this robusticity as an adaptive trade-off, sacrificing raw strength for greater energy efficiency and reproductive capacity. But this explanation becomes questionable when we examine female Neanderthal reproduction and population growth. Despite their physical power, evidence suggests Neanderthal women successfully reproduced at rates sufficient to maintain stable populations across Europe for over 300,000 years. Their robusticity didn't appear to compromise fertility or maternal survival, as the traditional narrative suggests. This raises a profound question. If Neanderthal women could maintain both extraordinary physical capability and successful reproduction, why did these traits disappear from the human lineage? What changed in our species' trajectory that rendered such capabilities unnecessary or disadvantageous? The stakes escalate further when we consider modern human health. Many contemporary health issues stem directly from our relatively gracile skeletons and reduced muscle mass. Lower back problems, joint instability, osteoporosis, and injuries related to weakened connective tissues. These conditions affect modern females disproportionately. Osteoporosis, in particular, represents a significant health burden for aging women today. Yet Neanderthal females appear to have maintained exceptional bone density throughout their lives, despite the demands of reproduction. Could understanding how Neanderthal women maintained such physical robusticity while successfully reproducing hold keys to addressing these modern health challenges? The potential medical implications extend beyond academic curiosity to practical interventions for contemporary populations. The stakes extend to our understanding of human cognitive evolution as well. The traditional narrative positions the Neanderthal brain as inferior, focused on concrete environmental interaction rather than abstract symbolic thought. But this interpretation increasingly appears questionable. Neanderthal brains were actually larger than those of modern humans, with particular development in areas associated with visual processing, spatial cognition, and motor control. Neural adaptations crucial for navigating complex environments and executing precise physical tasks. Female Neanderthals possessed these same neural specializations. Their brains represent a different cognitive adaptation, not inferior to the Homo sapiens pattern, but specialized for different environmental challenges and subsistence strategies. What if our species didn't simply evolve better brains, but different ones, trading certain cognitive capabilities for others? The emerging evidence suggests we may have lost specific forms of intelligence that Neanderthals possessed rather than simply developing superior cognition. This possibility fundamentally challenges how we conceptualize human cognitive potential. Rather than a linear progression toward increasingly abstract thought, human cognitive evolution may represent a series of trade-offs, gaining certain capabilities while losing others. The stakes escalate dramatically when we consider the implications for understanding gender and biology. For centuries, human societies have justified gender inequality by appealing to supposedly immutable biological differences, particularly regarding physical capability. But if Neanderthal women routinely possessed physical strength exceeding that of modern human males, these supposed biological constants become questionable. The gap between male and female physical capability appears more culturally constructed than biologically determined. This raises profound questions about human potential. If female strength capacity was radically different in our evolutionary cousins, what aspects of modern gender performance reflect biology versus cultural conditioning? How much of what we consider natural is actually constructed? The potential for misunderstanding increases when we consider how recently these discoveries have emerged. For over a century, paleoanthropology interpreted Neanderthal remains through a distinctly male lens, emphasizing hunting, territorial competition, and male dominance. When researchers finally began examining female Neanderthal remains with equal attention, and without assuming modern gender roles applied to prehistoric populations, an entirely different picture emerged. This revolution in understanding happened only within the past 2 decades. What other aspects of human evolutionary history have we fundamentally misunderstood due to similar biases? How many other assumptions about human nature, gender, and biological potential remain constrained by cultural preconceptions rather than evidence? The stakes extend to how we interpret human genetic diversity today. The Neanderthal genetic contribution to modern humans isn't randomly distributed. Certain populations carry higher percentages than others, with non-African groups showing the greatest Neanderthal genetic influence. This pattern results from historical population movements and interbreeding events rather than any meaningful difference in evolutionary advancement. Yet these genetic differences have sometimes been misused to support racist ideologies and hierarchy claims. Understanding the true nature of Neanderthal contributions, particularly those from Neanderthal women, becomes crucial for countering such misinterpretations. Their genetic legacy appears concentrated in immune function, skin and hair properties, and certain neural adaptations. These represent environmentally adaptive traits rather than general improvements or deficiencies. The evidence suggests Neanderthal genetic contributions provided specific advantages in certain environments, adaptations for cold climates, pathogen resistance, and environmental interaction. Perhaps the most profound stakes concern how we understand human potential itself. If Neanderthal women possessed physical and cognitive capabilities that differ substantially from both modern females and males, our conception of human possibility requires radical expansion. Rather than a narrow range of natural human capabilities, the evidence suggests tremendous plasticity in our lineage. Physical and cognitive adaptations can shift dramatically within evolutionary timeframes in response to environmental pressures and cultural practices. This insight holds particular significance in an era of rapid technological change and environmental transformation. Understanding how drastically human capabilities have already changed challenges fatalistic assumptions about biological limits and opens possibilities for conscious adaptation. The story of Neanderthal women forces us to confront uncomfortable questions about what we've lost in our evolutionary journey. Their physical power, environmental knowledge, and specialized cognitive adaptations represent capacities that largely disappeared from our lineage. The traditional narrative frames this as progress, sacrificing brute strength for intelligence, social complexity, and technological innovation. But this comforting story becomes questionable when we examine what Neanderthals actually achieved during their 300,000-year existence. They survived multiple ice ages and interglacial periods, dramatic climate shifts far exceeding anything experienced in recorded human history. They developed sophisticated technologies perfectly adapted to their environments. They created symbolic objects and potentially art forms. Most significantly, they maintained successful populations across Europe and Western Asia for hundreds of thousands of years, far longer than our species has existed. Their eventual disappearance coincided precisely with the arrival of Homo sapiens in their territories. This timing raises the most provocative question of all. Did Neanderthals disappear because they were evolutionary failures, or because of direct competition and absorption by our ancestors? The evidence increasingly points toward the latter scenario. If Neanderthals, particularly Neanderthal women, possessed remarkable adaptations perfectly suited to ice age environments, their disappearance may represent not evolutionary progress, but the loss of valuable genetic and cultural diversity from the human lineage. This possibility challenges our fundamental creation myth as a species. Rather than clever Homo sapiens inevitably replacing primitive predecessors, we may need to confront a more complex and morally ambiguous story, one where our ancestors potentially contributed to the extinction of another human species. What makes this particularly significant is the emerging evidence regarding Neanderthal cognitive and cultural complexity. If they possessed sophisticated language, symbolic thought, and social structures comparable to early Homo sapiens, their disappearance represents a profound loss of human diversity. The stakes culminate in a single, central question. Are we the only kind of human that could have existed in the modern world? Or did contingent historical events, climate fluctuations, population dynamics, technological innovations, determine which human lineage would ultimately predominate? This question has taken on new urgency with recent discoveries from Denisova Cave in Siberia. Here, archaeologists found evidence of a hybrid individual, a female with a Neanderthal mother and Denisovan father, representing first-generation offspring of two different human species. The implications are staggering. Different human species weren't just occasionally interbreeding. They were producing viable offspring capable of survival to adulthood. The boundaries between human groups were far more fluid than previously recognized. The implications are staggering. Different human species weren't just occasionally interbreeding. They were producing viable offspring capable of survival to adulthood. The boundaries between human groups were far more fluid than previously recognized. What if, rather than inevitable replacement, human evolution could have followed multiple viable pathways? What if Neanderthals, or a hybrid population combining Neanderthal and Homo sapiens characteristics, could have become the dominant human form under slightly different circumstances? This possibility fundamentally challenges how we understand ourselves and our place in nature. The traditional narrative of inevitable human progress gives way to a more complex story of contingent events, multiple possibilities, and paths not taken. And at the center of this mystery stands the Neanderthal woman, a figure whose extraordinary capabilities force us to reconsider everything we thought we knew about human potential, gender biology, and the very meaning of evolutionary success. Most provocatively, recent genetic research has identified specific Neanderthal genes that influence modern human brain development and function. These neural genes aren't random fragments, but carefully selected elements that offered advantages in specific environments and contexts. What might these genes tell us about Neanderthal cognitive capabilities, particularly those of Neanderthal women, who appear to have contributed disproportionately to our genetic heritage? What aspects of their mental world persist within us, unrecognized but potentially accessible? These questions aren't merely academic. They hold profound implications for how we understand human diversity, potential, and future adaptation. If Neanderthal genes continue to influence aspects of our cognition and physiology, understanding their original function becomes crucial. As climate change accelerates and humans face unprecedented environmental challenges, the adaptive strategies that allowed Neanderthals to survive multiple ice ages may hold vital lessons. Their existence proved human adaptability extends far beyond our current parameters. The ultimate stakes involve nothing less than our definition of humanity itself. If multiple human species coexisted, interbred, and contributed genetically and culturally to our lineage, the boundaries we've constructed between human and other become increasingly arbitrary. The story of the Neanderthal woman reveals how profoundly we've misunderstood our own evolutionary history, and by extension, our biological potential. Their extraordinary capabilities weren't evolutionary dead ends, but adaptive responses to specific environmental challenges. As we face an uncertain future of rapid environmental transformation and technological change, understanding the full spectrum of human adaptive capacity becomes increasingly urgent. The Neanderthal woman's story isn't just about the past, but about possibilities for our future. And now, as we prepare to examine the most controversial evidence yet discovered, we must confront the possibility that the traditional narrative of human uniqueness and inevitable progress may be not just incomplete, but fundamentally misleading. Chapter 8: Competing Theories: The Battle for Prehistoric Truth. As evidence mounts regarding the extraordinary capabilities of Neanderthal women, the scientific community has split into competing camps, each offering different explanations for their remarkable physical prowess, their social roles, and ultimately their disappearance. Three dominant theories have emerged, each with significant supporting evidence. The first theory, termed the environmental adaptation model, proposes that Neanderthal female robusticity evolved primarily in response to harsh ice age conditions. Proponents argue that extreme cold and resource scarcity created selection pressures favoring physical strength regardless of sex. In this model, the muscular development and bone density observed in female Neanderthal remains represent direct adaptations to survival challenges rather than specific social roles. Strong women were simply better equipped to survive European winters, process animal resources, and care for offspring. Supporting evidence comes from climate reconstructions showing the extreme conditions Neanderthals endured. During glacial maximums, temperatures in their territories could drop 15 to 20 degrees below modern averages, creating energetic demands far exceeding those faced by most modern humans. Studies of contemporary cold-adapted human populations show increased muscle mass and basal metabolic rates compared to populations from warmer regions. Neanderthal physiology may represent an extreme version of these same adaptations, with females developing robusticity for basic survival. This theory explains why Neanderthal women maintained such strength despite reproduction demands. In environments where calories were scarce and cold stress constant, robust females would have higher survival rates and reproductive success, creating strong selection pressure for these traits. Critics counter that this doesn't adequately explain the specific pattern of muscle development seen in female remains, particularly the pronounced upper body strength and powerful hand grip that align with hunting and tool use rather than general cold adaptation. The second major theory, the female hunter model, takes a more revolutionary stance. It proposes that Neanderthal societies practiced fundamentally different gender dynamics than previously assumed, with females routinely participating in hunting activities alongside males. Proponents point to the identical injury patterns found in male and female remains, trauma profiles consistent with close-quarter hunting techniques rather than domestic accidents. They note that modern gender roles may have blinded researchers to this possibility for decades. This theory aligns with the isotopic evidence showing similar dietary profiles between sexes. If Neanderthal women weren't directly involved in hunting, we would expect different nutritional signatures. But male and female remains consistently show nearly identical animal protein consumption. Recent biomechanical analysis strengthens this case. Female Neanderthal arm bones show development patterns specifically adapted for powerful rotational movements, precisely the motion required for thrusting spears into large animals during close-quarter hunting. The female hunter model suggests Neanderthal societies may have organized hunting activities based on individual capability rather than rigid gender divisions. In small bands where every member's contribution was crucial for survival, excluding capable females from hunting would be maladaptive. Critics argue this interpretation projects modern gender equality concerns onto prehistoric populations. They question whether pregnancy and nursing would have been compatible with high-risk hunting activities, regardless of physical capability. Proponents counter that contemporary hunter-gatherer societies show far more variation in gender roles than previously recognized. They note that female hunting participation has been documented in multiple modern foraging groups, particularly in resource-scarce environments. The third major theory, the sexual selection model, takes yet another approach. It proposes that Neanderthal female robusticity evolved through sexual selection processes, specifically, that Neanderthal males preferred physically powerful females as mates. In this model, female strength became an attractive trait, signaling survival capability in harsh environments. Over generations, this preference created selection pressure for increasingly robust females, independent of the direct survival advantages these traits conferred. Supporting evidence comes from comparative studies of other mammalian species where female robusticity is valued in mate selection. In environments where offspring survival depends on maternal strength and resilience, males often prefer physically capable females. This theory potentially explains why Neanderthal women maintained such extraordinary strength despite the metabolic costs. If robusticity increased mating opportunities and reproductive success, the energetic investment would be evolutionarily justified. Critics note that sexual selection typically produces traits that differ dramatically between sexes rather than convergence. They question whether this mechanism adequately explains why Neanderthal females developed strength profiles more similar to males than seen in most primate species. Each of these theories offers partial explanation, but none fully accounts for all evidence. The reality likely involves complex interaction between environmental pressures, social organization, and reproductive strategies that we're only beginning to understand. The environmental adaptation model explains the general trend toward robusticity in both sexes, but doesn't fully account for the specific pattern of muscle development in female remains. The female hunter model explains activity-related bone development, but raises questions about reproductive trade-offs. The sexual selection model offers insight into potential evolutionary mechanisms, but doesn't fully explain the specific physical adaptations observed. The truth may incorporate elements from all three explanations, reflecting the complex reality of prehistoric adaptation. What makes this scientific debate particularly challenging is the limited nature of the fossil record. While new analytical techniques have dramatically expanded what we can learn from ancient remains, we're still working from a relatively small sample of individuals. Approximately 500 Neanderthal individuals have been discovered to date, with complete skeletons numbering fewer than 20. Of these, only a handful are definitively female. Our entire understanding of Neanderthal women comes from this limited sample. This raises important questions about representation. Do the remains we've discovered accurately reflect the full spectrum of Neanderthal female variation? Archaeological sampling biases may be influencing our interpretations in ways we don't fully recognize. Recent discoveries have consistently expanded our understanding of Neanderthal capabilities rather than confirming earlier, more limited views. This suggests our current knowledge may still substantially underestimate their cognitive and physical adaptations. The competing theories raise fundamental questions about human adaptation and gender biology. If Neanderthal women routinely possessed physical capabilities exceeding those of modern human males, what implications does this have for our understanding of human potential? All three theories challenge conventional narratives about human evolution. Whether female robusticity evolved through environmental pressure, social role expansion, or sexual selection, the evidence indicates gender biology is far more plastic than previously recognized. This debate extends beyond academic discourse to fundamental questions about human nature. If different human species developed radically different gender expressions and social arrangements, how much of what we consider natural is actually culturally constructed? The resolution of this scientific controversy will require not just more fossils, but new analytical approaches, techniques that examine remains without imposing modern assumptions about gender, that consider alternative social arrangements, and that recognize the complex interaction of biology and culture. What's clear is that each new discovery pushes us further from the traditional narrative. Regardless of which theory ultimately predominates, the emerging portrait of Neanderthal women reveals capabilities and adaptations that challenge our most basic assumptions about human potential. Chapter 9. Breaking news. Science at the frontiers. The landscape of Neanderthal research is transforming rapidly, with technological advances yielding insights that would have been impossible even a decade ago. Perhaps the most revolutionary development comes from ancient protein analysis, a technique allowing researchers to identify sex in fragmented remains where DNA has degraded beyond recovery. This methodology, known as proteomics, examines amino acid sequences in surviving proteins, particularly those found in tooth enamel. Unlike DNA, these proteins can survive for hundreds of thousands of years, providing biological information from specimens previously impossible to analyze. When researchers applied this technique to Neanderthal remains from across Europe, a startling pattern emerged. Approximately 40% of adult Neanderthal specimens previously assumed male based on robusticity were definitively identified as female through protein markers. This single discovery has forced a fundamental reassessment of everything we thought we knew about Neanderthal sexual dimorphism. The physical differences between males and females were far less pronounced than previously assumed, with females routinely developing masculine muscle markers. Even more revolutionary findings have emerged from paleogenomics, the analysis of ancient DNA. Advances in extraction and sequencing techniques now allow researchers to recover genetic information from specimens up to 400,000 years old, dramatically expanding our window into Neanderthal biology. Genetic analysis confirms Neanderthal women possess gene variants associated with increased muscle development, bone density, and oxygen-carrying capacity. These weren't random mutations, but selected adaptations conferring specific advantages in their environment. Particularly significant is the identification of ACTN3 gene variants in Neanderthal females, a gene associated with fast-twitch muscle fiber development and explosive power in modern humans. Elite power athletes today often carry specific variants of this gene. Neanderthal women possessed these performance-enhancing variants at higher frequencies than seen in any modern human population. Their genetic blueprint encoded physical capabilities exceeding those of contemporary Olympic athletes, particularly in upper body strength. Equally revolutionary discoveries have emerged from microstratigraphic analysis of living sites, techniques that can identify activity patterns at microscopic scales. These methods reveal activity areas and material processing invisible to earlier archaeological approaches. When researchers examined Neanderthal hearth sites using these techniques, they discovered distinctive processing areas surrounding fire features, zones where different materials were worked, food prepared, and tools manufactured. The distribution of residues and wear patterns shows no clear gender segregation in activity areas. The traditional assumption that females worked exclusively in certain zones while males occupied others simply isn't supported by microscopic evidence. Instead, the pattern suggests integrated activity areas where different tasks were performed in close proximity, a social arrangement where capability rather than gender likely determined task allocation. This contradicts decades of assumptions about prehistoric gender divisions. Perhaps the most provocative recent discovery comes from analyzing cave art using advanced imaging techniques. By examining previously invisible spectral signatures, researchers can now identify individual handprints with unprecedented precision. When these techniques were applied to famous cave sites in France and Spain, researchers made a startling discovery. Approximately 45% of the handprints previously assumed to be male based on size were actually female, based on finger length ratios and ridge patterns. This finding fundamentally challenges assumptions about prehistoric art and symbolic expression. If Neanderthal women participated equally in creating these images, our understanding of prehistoric cognitive development and symbolic behavior requires complete revision. Equally significant discoveries come from dental calculus analysis, examination of mineralized plaque on teeth that preserves microscopic evidence of diet, health, and activities. This technique has revealed Neanderthal women routinely used their teeth as tools. Their dental calculus contains microfibers and wear patterns suggesting they used their mouths as third hands during material processing, holding animal hides, plant fibers, and other materials while working them with their hands. These weren't occasional behaviors, but lifelong practices. This evidence directly contradicts assumptions about gendered activities. The identical patterns in male and female dental remains suggest Neanderthal women routinely performed the same physically demanding processing tasks as men throughout their lives. New dating techniques have revealed another revolutionary finding. Neanderthals and early Homo sapiens coexisted in Europe for approximately 5,000 to 10,000 years. This extended period of interaction provided ample opportunity for cultural and genetic exchange between populations. This lengthy coexistence contradicts the narrative of rapid Neanderthal displacement. Instead, it suggests a complex period of interaction, competition, and ultimately incorporation, with Neanderthal genes, technologies, and potentially cultural practices absorbed into expanding Homo sapiens populations. Particularly significant is evidence that this interaction wasn't uniformly hostile. Multiple archaeological sites show technologies combining elements from both traditions, composite tools incorporating Neanderthal design features with Homo sapiens manufacturing techniques. These hybrid technologies appear during precisely the period when genetic evidence indicates interbreeding occurred. They suggest knowledge exchange and cultural learning between populations rather than simple replacement or elimination of Neanderthal techniques. The genomic evidence further complicates this story. Analysis of ancient DNA suggests gene flow between Neanderthals and Homo sapiens was predominantly directional, Neanderthal females breeding with Homo sapiens males rather than the reverse. This pattern raises profound questions about the nature of these interactions. Were they cooperative arrangements between groups, individual choices, or something more troubling? The archaeological and genetic evidence alone cannot determine the social context of these encounters. What's clear is that Neanderthal female biology has left a significant imprint on our species. Between 1 to 4% of non-African human DNA comes from Neanderthals, with specific adaptive genes reaching much higher frequencies in certain populations. These aren't random genetic fragments, but selected traits that offered advantages in specific environments. Immune functions, skin and hair properties, fat metabolism adaptations, and certain aspects of brain development. Neanderthal female biology continues within us. The paradox deepens when we consider Neanderthal reproductive biology. Pelvic reconstructions suggest they gave birth to infants with larger cranial capacities relative to maternal size than modern humans, a challenging adaptation requiring substantial skeletal modifications. Yet despite these reproductive demands, female Neanderthals maintained extraordinary physical robusticity throughout their lives. This contradicts expectations that reproduction and muscle development would represent competing metabolic priorities. New research into Neanderthal childhood development provides potential insight into this paradox. Evidence suggests their children developed more rapidly than those of Homo sapiens, reaching physical maturity earlier while still requiring extended learning periods for complex skills. This developmental pattern would have allowed Neanderthal women to resume physically demanding activities sooner after childbirth. The metabolic demands of nursing would still be substantial, but the period of intensive infant care may have been shorter. These revelations create a scientific paradox. If Neanderthal females possessed such remarkable adaptations, physical strength, cognitive specialization for their environment, successful reproductive strategies, why did these traits largely disappear from the human lineage? The traditional explanation that our species simply outcompete them through superior intelligence becomes increasingly untenable as evidence of Neanderthal capabilities grows. Their disappearance cannot be explained by simple evolutionary inferiority. Climate reconstructions suggest another contributing factor. The period of Neanderthal decline coincided with dramatic environmental fluctuations, rapid warming and cooling cycles that transformed European landscapes more quickly than at any previous point in their evolutionary history. These changes would have disrupted the predictable environmental patterns to which Neanderthals had adapted over hundreds of thousands of years. Their specialized adaptations, perfect for stable cold conditions, may have become less advantageous in rapidly changing environments. Yet this explanation alone remains insufficient. Climate change affected all human populations in Europe, not just Neanderthals. If environmental factors were the primary driver of their disappearance, we would expect similar impacts on early Homo sapiens groups. The paradox deepens when we consider population dynamics. Genetic evidence suggests Neanderthals maintained relatively low population densities throughout their existence, an adaptation suited to their high-energy physiology and hunting-intensive subsistence strategy. In contrast, early Homo sapiens appears to have maintained higher population densities and growth rates. When the species encountered each other, this demographic difference alone may have tipped the balance regardless of individual capabilities. These paradoxes force us to reconsider what constitutes evolutionary success. Neanderthals survived as a distinct lineage for over 300,000 years, far longer than our species has existed. Their disappearance as a distinct population doesn't negate the remarkable adaptations they developed. Perhaps the most profound scientific paradox emerges when we consider their genetic legacy. While Neanderthals disappeared as a distinct population, their genes, particularly those contributed by Neanderthal women, continue within our species, influencing human biology today. This suggests not replacement, but incorporation. Neanderthal female biology absorbed into the expanding human lineage through interbreeding. The traditional narrative of competitive exclusion gives way to a more complex story of genetic and cultural exchange. Chapter 10. The evolutionary truth finally revealed. We've journeyed through evidence, examined competing theories, and explored recent scientific breakthroughs. Now we arrive at the central revelation that ties these threads together: the true story of Neanderthal women and what their existence reveals about human potential and evolution. The evidence converges toward a revolutionary conclusion. Neanderthal women weren't merely strong by modern standards. They represented an entirely different model of female human potential, one optimized for direct environmental interaction rather than the social specialization that came to dominate our lineage. Their physical capabilities weren't anomalies or exaggerations, but adaptations perfectly suited to their ecological context. In the harsh environments of Ice Age Europe, female strength, endurance, and environmental knowledge translated directly to survival and reproductive success. The traditional narrative portraying them as subordinate figures in male-dominated groups collapses under scrutiny. The physical evidence suggests Neanderthal women routinely participated in the full spectrum of survival activities: hunting, processing, technological innovation, and childcare. Rather than rigid gender divisions, Neanderthal social structures likely featured task allocation based on individual capability and contextual needs. In small, interdependent groups facing harsh conditions, excluding capable females from crucial activities would have been maladaptive. This social flexibility represented not primitive underdevelopment, but sophisticated adaptation. Their arrangements weren't failed attempts at modern gender structures, but different solutions to survival challenges, solutions that worked successfully for hundreds of thousands of years. The central revelation emerges when we consider what happened when these remarkable women encountered our ancestors. Genetic evidence tells an extraordinary story. Neanderthal female biology was selectively incorporated into the human lineage through interbreeding with Homo sapiens males. This wasn't random absorption, but selective integration. Specific Neanderthal genes conferred advantages in the European environments where our ancestors were newcomers. Their cold adaptations, immune responses, and metabolic efficiencies represented valuable innovations for our lineage. Most significantly, this genetic exchange appears predominantly directional: Neanderthal females with Homo sapiens males. This pattern suggests these women made reproductive choices that ultimately ensured their genetic legacy would continue within the expanding human population. Rather than evolutionary failure, this represents a different kind of success: genetic continuity through incorporation rather than independent persistence. Their lineage didn't simply disappear, but transformed, becoming part of our species' genetic architecture. The true story isn't one of replacement, but of merger: two human lineages with different adaptations and capabilities combining through interbreeding. The traditional narrative of superior Homo sapiens outcompeting primitive Neanderthals gives way to a more complex evolutionary reality. This revelation forces us to reconsider what we mean by evolutionary progress. The conventional view positions modern humans as unambiguously improved versions of our ancestors: more intelligent, more adaptable, ultimately more successful at colonizing diverse environments. But the Neanderthal woman's story reveals a different pattern, one where our species didn't simply evolve better adaptations, but different ones. We sacrificed certain physical capabilities while developing others, particularly social intelligence and technological innovation. This wasn't straightforward improvement, but trade-off, gaining certain advantages while losing others. The extraordinary strength, environmental adaptation, and specialized cognition of Neanderthal women represent capabilities our lineage largely surrendered during our evolutionary journey. What makes this revelation particularly significant is how it contradicts popular understanding of human potential. We've constructed narratives positioning physical strength as inherently masculine, while assuming female biology necessarily constrains power output and muscular development. Neanderthal women demolished these assumptions. Their skeletal remains demonstrate that female humans can develop physical capabilities exceeding those of modern male athletes without compromising reproductive function, a possibility our cultural narratives have largely erased. Their existence proves human biological potential extends far beyond contemporary parameters. The physical capabilities we consider exceptional today, Olympic-level strength, endurance, and resilience, likely represented baseline functioning for Neanderthal women. This insight holds profound implications for how we understand human adaptation. Rather than fixed biological constraints, our capabilities represent responses to specific environmental and cultural contexts. Change those contexts, and human biology can transform dramatically. The revelation extends to our understanding of gender itself. If different human lineages developed radically different patterns of sex-based physical development, gender dimorphism cannot be a biological constant, but a variable shaped by environment, subsistence strategies, and cultural practices. This doesn't mean biological sex lacks influence on physical development. Rather, it reveals how the expression of those influences varies tremendously based on environmental demands, dietary factors, activity patterns, and cultural expectations. Neanderthal women demonstrate this plasticity. Their biology responded to their life demands with extraordinary adaptation, developing muscle mass, bone density, aerobic capacity, and cold resistance far exceeding what we typically consider possible for female humans. The central insight isn't that biological sex has no influence, but that its expression is far more variable than commonly recognized. Human potential, both physical and cognitive, exists along continuums that respond dynamically to environmental demands and cultural contexts. This revolutionary understanding has begun transforming multiple scientific disciplines. Evolutionary psychology is reconsidering fundamental assumptions about gender roles based on Neanderthal evidence. Sports science is re-examining the limits of female physical performance. Medical researchers are investigating Neanderthal genes that influence modern human metabolism, bone density, and muscle development. Their adaptations may hold keys to addressing contemporary health challenges, particularly those affecting female skeletal and muscular health. Anthropologists are re-examining archaeological remains with new awareness of how gender biases have shaped interpretations. Sites previously analyzed through assumptions about rigid prehistoric gender roles are yielding new insights when examined without these preconceptions. The revelation about Neanderthal women doesn't just change how we understand them. It transforms how we understand ourselves. Their existence proves human potential isn't fixed, but remarkably adaptable, capable of developing in directions we've scarcely imagined. Perhaps the most profound aspect of this revelation concerns what it means to be human. For centuries, we've constructed narratives positioning Homo sapiens as the pinnacle of evolution, the one true human species, destined for dominance through superior capabilities. Neanderthal women challenge this comforting story. They represent not failed humans, but different humans, beings with remarkable adaptations perfectly suited to their environmental context. Their disappearance reflects not inferiority, but the contingent nature of evolutionary history. Had climate patterns, population dynamics, or technological developments unfolded differently, Neanderthals might have persisted as a distinct lineage. Their adaptations, particularly female physical capabilities, might have remained part of active human diversity rather than genetic fragments. This revelation transforms our origin story from triumphant progress to complex interaction. Different human lineages with different capabilities encountering each other, competing in some contexts, cooperating in others, ultimately merging genetically and perhaps culturally. The true story of human evolution isn't linear advancement, but network. Multiple human species with different adaptations exchanging genes, technologies, and potentially cultural practices. Our species didn't simply replace others, but incorporated aspects of their biology. Neanderthal women stand at the center of this revelation. Their extraordinary capabilities weren't evolutionary failures, but successful adaptations to specific environmental challenges. Their genes continue within us not as vestigial remnants, but as valuable adaptive traits. This understanding doesn't diminish human achievement, but enriches it. Our lineage represents not the only way to be human, but one expression of human potential, a specific set of adaptations that proved successful in certain contexts while sacrificing capabilities developed by other human species. The ultimate revelation isn't that Neanderthals were inferior or superior to Homo sapiens, but that they were different. Humans adapted for direct environmental interaction rather than the social specialization that came to dominate our lineage. Their women embody this difference most dramatically. Their physical power, environmental knowledge, and specialized cognition represent a fundamentally different expression of female human potential, one optimized for survival in harsh environments through direct engagement rather than social mediation. This revelation doesn't just change how we understand our past, but opens possibilities for our future. If human biology has already demonstrated such remarkable plasticity, our potential for adaptation to new challenges may be greater than we've imagined. As our journey through the evidence concludes, we return to where we began, those delicate handprints pressed into clay 40,000 years ago. With new understanding, we see them differently now, not as passive impressions left by subordinate figures, but as signatures of remarkable beings whose capabilities we've only begun to comprehend. The story of Neanderthal women reveals not just scientific facts, but profound philosophical insights. It challenges our assumptions about human nature, gender, and evolutionary progress. It forces us to confront the contingent nature of our existence and the multiple ways of being human that have existed. Their physical power reminds us that human potential extends far beyond contemporary parameters. Their apparent social arrangements suggest gender roles aren't biologically determined, but culturally constructed. Their disappearance challenges triumphalist narratives about human progress. Yet their genetic legacy continues within us, fragments of Neanderthal female biology influencing everything from our immune responses to aspects of our brain development. They aren't merely subjects of academic study, but part of who we are as a species. Perhaps the most profound lesson comes from recognizing that different human lineages develop different, but equally valid adaptations. Neanderthal women weren't failed humans, but different humans, beings whose remarkable capabilities were perfectly suited to their world. As we face unprecedented environmental challenges in our own time, their story offers both caution and inspiration. Caution that even successful adaptations can prove vulnerable to rapid change. Inspiration that human potential includes capacities we've scarcely begun to explore. The next time you look at your hands, remember those ancient handprints. Within your genome echo fragments of those extraordinary women, a biological memory of different human possibilities. Their story isn't finished but continues through us, reminding us that what we consider human remains wonderfully, mysteriously unfinished. If you've enjoyed this exploration of our complex human story, subscribe to our channel for more journeys into the mysteries that science is still debating. Together, we'll continue unraveling the forgotten truths that reshape our understanding of what it means to be human.